All right, unlike the first three problems, this one is more challenging. It's number 50. It's a number 55 problem, so the ACT goes from 1 through number 60. They get progressively harder. So 55 out of 60, this is definitely one of the harder ones. Again, we see that there are variables in the answer choices, so this is a candidate to pick numbers and then plug back in. So let's read it. If x and y are real numbers such as x, such that x is greater than 1 and y is less than -1. So let's go ahead and just pick numbers for this. So if x is greater than 1, let's say x is 6, and y is less than -1, let's say y is -7. Then which of the following inequalities must be true? So this is key here, must. It means it's true all the time. We may have to experiment with different numbers here, by the way. So we may not, we can't, unlike the other ones, just keep 6 and -7. We may have to experiment here because we have to figure out if it's true for all numbers that's x greater than 1, y is less than -1. So x over y is greater than 1. That means 6 over -7 or -6/7 is greater than 1. And that is not true. Again, it's not going to be true for anything because any positive and negative combination, when you divide a positive by a negative or a negative divided by a positive, it's going to be negative. So it can never be greater than 1. So this is definitely false. Now let's check B out. Absolute value of x squared, well, absolute value of 6 is 6. So 6 squared, which is 36, is greater than absolute value of -7, which absolute value of -7 is 7. Well, this is true here, but is it true for anything? Let's switch around some of the numbers. What happens if x, let's say x is 2 and y is -7? That means this would be 4 is greater than 7. So this is what I mean by experimenting with different numbers. So 4 is not greater than 7. So this is not true. Again, must be true. So yeah, if we switch around some of the numbers, it doesn't work. Let's look at this one. This one looks kind of complicated. A little trick, if we have on both sides, if this inequality, or let's say this was an equal sign or an inequality, if we have the same types of things on both sides, we can cross it out. Like we see a -5, -5. Let's get rid of it. We can cancel it out because we could add by 5 for both sides. Again, divided by 3, divided by 3. Well, we could multiply 3 by both sides. So this is just saying x is greater than y. So we can easily simplify this. So again, let's try our numbers. Is 6 greater than -7? Yes. Is 2 greater than -7? Yes. So any combination, I don't care what number you pick for x and y, this is going to be true. So try any combination of numbers you want. It will never, this always must be true. So we can actually stop with C because we know C is correct, but let's just do these other ones. Again, see how it says +1, +1? You can simplify it and just say that this is x squared is greater than y squared. So x squared is greater than y squared. Let's go back to the numbers we picked. Again, is 36 is 6 squared greater than -7 squared. Any negative number raised to an even power is going to be positive, by the way. So is 36 greater than 49? Nope. So we can get rid of that one. And this. raised to the x raised to the negative 2 is basically 1 over x squared. Is that greater than 1 over y squared? So when we have fractions, the greater the denominator means the less the actual value. So let's try x equals 6, y equals negative 7. 1 over 36 is greater than 1 over 49. So that works. But how about what happens if we change the numbers around? What happens if x is 10 and y is negative 1? Is 1 over 100 greater than 1 over negative 1 squared, which is 1? So is 1 over 100 greater than 1? Nope. So this one's wrong too. So anyways, a complicated problem, we can always experiment with numbers and get the right answer. In this case, we have to experiment with different numbers because of the case must be true. So here's another example of picking numbers. When we see variables in the answer choices, we can use this strategy. So we'll do some more of these problems here, but again, 55 is probably one of a good example, whether you're really good at math or not so good at math, where this picking numbers and plugging in strategy definitely helps. I'll see you in the next video.